Let's look at an example, namely permuting an array. So suppose you got a deck of cards from a card manufacturer, and those cards usually come in some, let's say, canonical order, beginning with the 2 of clubs, going on to the 3 of clubs, then to the ace of clubs, and then proceeding through diamonds, hearts, and spades. And so the deck is in some order, and if you tried to play a game with it in that particular form, everybody could cheat because everybody would know what the next card is. So to play a game, we really need to be able to shuffle the deck. And how can we do this? And this is an interesting thing to look at for the following reason. If I ask you to take a deck of cards and divide them perfectly in half, and then interleave the cards perfectly, one from each side of the split, that would be an almost impossible thing for a human to do. It's called a perfect shuffle, and you could try it on your own, but you're going to find it very difficult. Sometimes 2 cards will fly. Maybe you didn't divide the deck exactly in half when you started. It's a very difficult thing for a human to do. Now, a computer could do it, but I want to show why that's not such a great idea. And to illustrate a perfect shuffle, we're going to start with 8 cards, and they're labeled A through H here. We're going to divide them in half to create 2 piles. So we have on one side A through D, on the other side E through H. Let's mesh them together and then bring the deck together. And after one shuffle, we perfectly interleaved every other card from the left and right side of the split. But notice the top and bottom cards, A and H, didn't change. So the perfect shuffle, while it's perfect, didn't change the top card at all, and the bottom card is also the same. The other cards have changed, but let's do another round. So we'll take the result of the first shuffle, divide it perfectly in half, separate the 2 pieces, merge them together again, and again, the top and bottom card are undisturbed, but the middle cards still look kind of random, look like they've been shuffled. But let's divide them one more time in half, separate them, merge them, and shuffle. And after 3 perfect shuffles, a surprising thing happens. The cards are back in their original order. It would be interesting to consider how many rounds it would take for 16 cards to come back to the original order. And also we'll be thinking about how you formalize this idea of what is a reasonable shuffle of a deck and what makes for a fair deck for a game.